We have f of x equaling x plus 2 times the cosine of x on the interval from 0 to pi. So, you got cosine. He's going to look like that. But he has 2 cosine, so he's going to be a little taller. And he's actually he's going to go up a little bit. And so this guy kind of is going to look like this maybe because you're going up by x every time. So he's going to kind of keep but that doesn't matter because we have the power of calculus to actually work out this interval and find the critical numbers. So remember, the critical numbers all revolve around getting that derivative to equal 0. Okay, that's where all the action takes place. So let's go ahead and take the derivative here. The derivative of x is 1, and then this guy's going to be 2. The derivative of cosine is negative sine. So negative sine x. So this guy looks like 1 minus 2 sine x. And we're going to set this equal to 0. It's a little faint. Let's go a little darker here. All right, so we're going to set it equal to 0. We're going to move that 1 over to here. He'll become negative. And we're going to divide by negative 2, so we get a positive 1/2. All right, so this guy's definitely doable. We're only interested in the parts of the unit circle from 0 to pi, which is 0 to 180 degrees. And we want to know where sine equals a half. Okay, so x is going to equal 1/2 at the very beginning, pi over 6. And he'll also equal 1/2 on the other side, which would be 5 pi over 6. All right, so those are 2 instances where sine equals 1/2 because the derivative equals 0 there. Okay, so find the critical numbers. That's it. That's where it is. So find the open intervals in which this function is increasing or decreasing. Okay, so now we have pi over 6 and 5 pi over 6. Okay, and we want to know where this guy is positive or negative. Okay, and we know that the derivative is 0 here and here. All right. Okay, so now let's pick something that's less than pi over 6. And is this guy going to be positive? Let's see, pi over 6. And if you're just a little bit off of the x-axis, the sine value will definitely be positive. But let's see here. We've got positive, and then 1 minus 2 times. I'm going to actually have to pick a... How about we pick a radian that is like smaller than pi over 6, right? Because that way it would be to the left of it, right? So how about pi over 9? Okay, just pick it, pi over 9. So let's go 1 minus 2 times the sine of pi over 9. And we'll close it up, make sure we're in radians. And it looks like he's positive. Okay, so he is positive right there. My guess is that he's going to dip negative, but you don't know. Let's pick a number between, let's go pi over 2, okay? So let's go here. Let's copy that guy, hit 2, and you'll notice it's negative 1. So therefore, we'll go negative. All right, and then a number that's bigger than 5 pi over 6, but smaller than pi. So how about we go like 7 pi over 8. Let's do that. That fraction is not quite 8 pi over 8, which would be pi, but it's close. Okay, so let's go 7 pi over 8, close it up, and that is positive. All right, so we see our intervals of increase and decrease. This guy's increasing, this guy will decrease, this guy will increase. Okay, so increasing would be from, let's see, we're going from 0. Okay, our interval is from 0 to pi over 6, and then he will increase again after 5 pi over 6, and that's going to increase all the way to pi, and that's where it stops. Okay, but we do not include pi, we go right up to it. Okay, decrease is going to be the one in the middle here, from pi over 6 to 5 pi over 6. Okay, and together, notice that we're not including those critical values because that's where it actually hits 0. So our absolute extrema All right, our tallest points, let's see. To find our tallest points, first of all, we've got our critical values. Okay, so let's figure out what we know this pi over 6 is a max. Okay, because he increases then decreases. This guy's a min. Okay, but is he absolute? So let's figure that out. Let's find f of pi over 6. Let's find f of 5 pi over 6. Okay, now let's find also, you got to find the endpoints for absolute. So we got to find the f of 0, and then we got to find f of pi. Now all this is doing is just plugging it in. We're going to plug it into the original function. Okay, original function. So go all the way back to the very beginning. And what I'm going to do is I'm going to just type in x. Let's go, so pi over 6. Let's put parentheses, pi over 6. Okay, parenthesis, plus 2 times cosine of pi over 6. So notice that x is in 2 different locations. And we'll close it up. And we get let's just put 2.3. Now let's go to the hundreds. 2.26. Okay. Now we're going to go ahead and change that to 5 pi over 6. Put a 5 in front there. And then we're going to go second insert 5 right there. Hit enter. You get 0.89. Okay, now let's go 0. Two. All right, now we go f of pi. And we get 1.14. All right, so ABS max is the biggest number. It's at 2.26 at x equals pi over 6. All right, and then the absolute min is going to be the smallest number, which is 0.89 at x equals 5 pi over 6. So we did not use the endpoints. The endpoints were somewhere in the middle. So it's somewhere in the middle of the values. But these are our absolute max and absolute min. Okay, another video for the second problem.